Now, in our last couple of videos, we talked a lot about z-scores, so we can measure how many standard deviations an observation was from the mean, as well as in which direction. Z-scores will not be going away, so they will be showing up again, but we're going to be talking more about this normal distribution or normal model, or sometimes what students just refer to as the bell curve. So first, we're going to talk about some characteristics of this normal model and then see how that applies to our pictures down here. Some of you have probably seen this bell-shaped curve before. You may not have seen it with this scale along the bottom. We're going to talk about what that means here shortly. So it's overall characterized by being this bell-shaped curve. The two different things that we need to know for a normal distribution is its mean and its standard deviation, those same symbols that we were using when we were talking about the z-score. So that's right how you're going to see z showing up here again soon as well. It's symmetric about the mean. So what that is going to mean for it is there's 50% below it and 50% above it. And we're going to be using that rough estimate of this 50% to understand what our answer is going to be when we find some probability values later. So first, kind of looking at my picture, what I mean by where the mean would be is right where this peak occurs, down here along the bottom. That is actually where the mean is going to fall on my picture. So if I kind of draw a line right there, half of it's below it, half of it is above it. Now let's talk about this normal curve rule, or sometimes referred to as the empirical rule. This is true for any normal distribution. So 68% of the data is going to lie within one standard deviation of the mean. Well, what does that actually mean down here picture-wise? Well, it means I go from the mean and I go one standard deviation below it and one standard deviation above it, and draw my lines here. What that means is that I'm going to get 68% of my data within one standard deviation of the mean. All right, so how would I actually get this number along the bottom right here? Well, I'm going to take the mean and subtract off my standard deviation. So mathematically, that's going to be mu minus whatever sigma is. Up here, instead of subtracting the standard deviation, I'd be adding it to get above it. So this is going to be the mean plus the standard deviation. So that's where that 68% falls. I'm going to do the same thing with just a slightly different looking picture. Now the numbers along the bottom I'm not going to change. So that's still where the mean is going to occur. I'm still taking the mean minus a standard deviation and doing the mean plus a standard deviation. And I still am going to have 68% between my two values. But now I'm going to break this up a little bit. So suppose I don't want to look at this one big chunk. I want to break it up into these two smaller chunks. How much do you think would be in each of these pieces? Well, there has to be 68% total, and I have two different places to put it in. So it sort of seems like if I just take that 68% and divide it by 2, I'm going to get that I'm going to have 34% in this piece and 34% in that piece. So these two pictures are saying the same thing, it's just broken up a little bit differently. Does that one make sense? Because the next two we're going to build on that. So 95% of the data lies within two standard deviations of the mean. Looking here then at my graph with the blue lines on it, that means I'm just going to go out another standard deviation in both directions. And when I do that, this time I'm going to get 95% of my observations. Now, what will these numbers look like along the bottom? Well, to get to this spot, I started with the mean, and I'm subtracting the standard deviation twice. So that's going to be the mean minus 2 standard deviations. To get to this top spot, I'm taking the mean, but this time I'm adding 2 standard deviations. How is this going to work now on our red curve? Well, I'm not changing the numbers along the bottom, so there's my mean minus my 2 standard deviations, and my mean plus my 2 standard deviations. But now what I'd like to figure out is how much can I put in these 2 separate pieces? All right, so let's think this through. We have 68% between here and here, right? We have 68% between here and here. I need to have 95% between here and here, but I've already put 68% on my picture. So the first thing I'm going to do is subtract off that 68% that I already have on my picture, which means I'm left with 27% that I can put in these 2 spots. But not in each spot. In total, I can put 27% there. So just as before, I'm now going to take this leftover 27% that I can add. I'm going to divide it by 2 since I have 2 different spots to put it in. And that's going to get me 13.5% for this piece and this piece. Okay, so it was a little bit trickier, but what I now know is if I add up all the numbers that I got here, I'm going to get 95%. And I do. Right, we're extending it to one more standard deviation out. Our empirical rule or the normal curve rule tells us then that 99.7%, almost everything, falls within 3 standard deviations of the mean. Which means I'm going to go out another standard deviation on my blue graph here in both directions. And when I do that, I almost have everything. Not quite. That's why there's this very tiny, tiny bit there that I can't even really see that goes beyond that. So there's 99.7% of my data. What I had to do to get to this point is I had to subtract off a 3rd standard deviation. And to get out here, I would have to add a 3rd standard deviation. So again, I'm not really changing anything over here on my red curve. I'm just figuring out how to break it up into these pieces instead. So now I need to figure out how much I can put in these 2 pieces. Well, let's follow the same process I did before. In total, there's going to be 99.7% between these 2 spots. However, we've already put on how much into our picture. Well, after last time, I've made sure that there's 95% in total on my picture. So that means I can only add 4.7% more. But I have 2 different spots to split that up between. So that's going to give me 2.35% that I can put in these pieces. So that piece is going to be 2.35%, and this piece is going to be 2.35%. I do actually have a little bit more I want to add to that picture. Right, because I have 99.7% so far. But I know in total, everything adds up to 100%. And I've put 99.7% on my picture, which leaves me very, very little, only 0.3% that I need to put on my picture still. But I technically have two spots to put it in because that falls in this tiny dinky piece here, as well as this tiny dinky piece up here. So I'm going to take that same idea and divide this by our 2, since I have 2 spots to put it in, which gives me less than 1%, 0.15% is going to show up on either side of being more than 3 standard deviations away. So now my entire picture covers everything. I have 100%. Right, because if 99.7% falls within 3 standard deviations, that means that 0.3% fall out further. So there still is some chance of being out here. It's very unlikely, but there is a chance still of being out there. So that's what the normal distribution looks like. This is what the normal curve rule, or also known as the empirical rule, looks like. Our goal in the next video is to take these numbers and apply it to some problems to find some probabilities and to see how this relates to those z-scores that we were finding in the previous videos.